February 19th, 1943. Kasserine Pass, Tunisia. Technical Sergeant James Walker crouched inside his M4 Sherman tank as German shells screamed overhead, his throat microphone pressed against his larynx, his fingers adjusting the frequency crystal on the SCR-508 radio mounted in the turret bustle behind him. Baker 3 to Baker 6. Enemy armor advancing from bearing 270, estimate 2 companies. Request fire mission coordinates Hotel 73. The response came through his headphones instantly, crystal clear despite the roar of the Sherman's radial engine and the cacophony of battle outside. No static, no interference, just the calm voice of his battalion commander 3 miles away, coordinating a response that would involve 16 tanks, 4 artillery batteries, and close air support, all through the invisible web of radio signals that connected American forces across the Tunisian battlefield. This moment, repeated thousands of times across dozens of engagements, would reveal a truth that neither side fully understood at the war's beginning. The outcome of armoured warfare would not be determined solely by armour thickness, gun calibre, or engine horsepower. It would be decided by something far less visible: the quality, reliability, and tactical employment of radio communications systems that allowed tanks to fight not as individual vehicles, but as coordinated formations, executing complex maneuvers across miles of battlefield. The journey to this revelation had begun in fundamentally different places for the 2 armies that now clashed in North Africa. The story of American tank radio development begins not in 1943, but in July 1941, when the U.S. Army Signal Corps standardized the SCR-508 radio system at Fort Monmouth, New Jersey. The engineers who designed this system faced a specific challenge: how to maintain clear voice communications inside a steel box filled with mechanical noise, electrical interference, and the chaos of combat. The solution they developed would prove revolutionary. The SCR-508 utilized frequency modulation FM radio, operating in the 20 to 27.9 megacycle range. This choice was not arbitrary. FM radio possessed inherent characteristics that made it superior for mobile military communications. When amplitude modulation signals passed through the electrical storm generated by a tank's ignition system, generator, and drive motors, the interference manifested as static and noise that obscured voice communications. FM signals, by contrast, carried information in frequency variations, rather than amplitude changes. The electrical noise from tank systems affected amplitude but left frequency intact. The result: FM provided clear, intelligible voice communications, even in the most electrically hostile environment imaginable. The SCR-508 system consisted of 3 primary components mounted on the FT-237 rack. The BC-604 transmitter delivered 25 watts of output power sufficient for ranges of 7 miles while moving and 10 to 15 miles when stationary. 2 BC-603 receivers allowed simultaneous monitoring of different frequencies. The system's crystal-controlled tuning provided 10 preset transmission channels and up to 20 receiving channels if all frequency crystals were installed. The entire assembly weighed 181 pounds. It required either 12-volt or 24-volt power, which the Sherman's electrical system provided through dynamotors. The radio also integrated the tank's intercom system through BC-606 control boxes mounted at each crew station, allowing internal communication separate from external radio transmissions. Command tanks received an additional SCR-506 radio mounted in the right sponson. This secondary system operated in the 2 to 6 megacycle range, connecting battalion commanders to regimental headquarters while maintaining contact with their own units through the primary SCR-508. By early 1942, every M4 Sherman tank rolling off American production lines carried this sophisticated communications system as standard equipment. The turret bustle. The rear extension of the turret was specifically designed to accommodate the SCR-508's bulk. The radio was not an afterthought or optional equipment. It was integral to the tank's design from the beginning. This represented a fundamental commitment. American doctrine assumed that tanks would operate as networked units, coordinating their actions through continuous radio communication. The weight penalty, the production complexity, and the maintenance requirements were accepted as necessary costs for this capability. The German approach to tank communications emerged from different tactical requirements and different technological choices. Beginning in the mid-1930s, German armored doctrine emphasized rapid movement, mission-type tactics, and combined arms coordination. These concepts demanded reliable communications, and German designers responded by equipping every panzer with radio equipment. This fact bears emphasis because it contradicts a persistent myth. German tanks were universally equipped with radios by 1940. During the French campaign, when 80% of French tanks lacked any radio capability, German panzers dominated through superior command and control, enabled by near-universal radio equipment. This was one of Germany's key tactical advantages in the early war years. The standard German tank radio was the Funkgerät 5, or Fugue 5. This system operated as an AM transceiver in the 27 to 33.3 megacycle range with 10 watts transmission power. It provided 125 channels at 50 kHz spacing. Range was approximately 2 to 3 kilometers using amplitude modulation voice transmission, extending to 3 to 4 kilometers when using Morse code. The Fugue 5 used a 2-meter whip antenna and was installed in virtually all German tanks for platoon and company-level communications. Platoon commanders received an additional UKW E receiver to monitor neighboring platoons. Command tanks carried supplementary systems. The FUG-7 for higher-level command networks, operating in the 42 to 48.3 megacycle range at 20 watts, or the Fugue-8 for long-range communication to regimental command posts, operating in the 1.13 to 3 megacycle range at 30 watts. The German radio equipment was technically sophisticated, utilizing crystal-controlled tuning and multiple frequency options. The intercom systems, powered through specialized amplifiers like the Panzerkasten 20 introduced in 1941, allowed 4 of 5 crew members to communicate internally. But the Germans made a different fundamental choice than the Americans. They used amplitude modulation rather than frequency modulation. This decision reflected several factors. German radio engineers had extensive experience with AM technology. The components were well understood, mass-producible, and reliable. FM technology, while theoretically superior for mobile communications, was newer and less proven in 1935, when the Fugue 5 design was finalized. This choice would have consequences that became apparent only in combat conditions. The first major engagement between American and German armor occurred at Sidi Bou Zid on February 14, 1943, 3 days before Kasserine Pass. The battle exposed not only American tactical inexperience, but also revealed how radio technology influenced battlefield outcomes in ways that neither side had fully anticipated. Major General Lloyd Fredendall's U.S. 2 Corps had established forward positions in central Tunisia, with Combat Command A of the 1st Armored Division deployed around Sidi Bou Zid. The Americans positioned their forces in scattered strong points across complex terrain hilltop positions, separated by miles of open desert, a deployment that violated the principle of mutual support but reflected peacetime doctrine developed in isolation from European combat experience. When General Feldmarschall Erwin Rommel's Afrika Korps launched Operation Frühlingswind on the morning of February 14th, the German attack demonstrated the tactical flexibility that radio coordination provided. More than 100 Panzer III and Panzer IV tanks, organized into 2 armored columns, supported by mechanized infantry and self-propelled guns, swept through Fade Pass and enveloped the American positions. The German attack succeeded through superior tactical coordination enabled by their radio networks. Panzer commanders communicated directly with supporting artillery observers, with Luftwaffe forward air controllers, and with infantry units, all through established radio procedures that had been refined through years of combat experience. But the American defenders, though overwhelmed by the coordinated German assault, maintained their own communications network throughout the engagement. As American positions fell, battalion commanders received continuous reports from surviving units. The SCR-508 systems in retreating Shermans transmitted situation reports, called for artillery support, and coordinated withdrawal movements even as the tactical situation collapsed. Lieutenant Colonel John Waters, commanding a task force of Shermans attempting to relieve the surrounded American positions, maintained radio contact with his scattered units, despite being surrounded himself. The clarity of FM communications allowed complex coordination attempts that would have been impossible with static-prone AM systems, though in this case, tactical mistakes and numerical inferiority negated any communications advantage. The battle cost the Americans 1,600 casualties, 98 tanks, 57 half-tracks, and 29 artillery pieces. German losses were significantly lighter. But the communications systems themselves had performed as designed on both sides. The defeat came from tactical errors, not technological failure. What American commanders learned from Sidi Bouzid and the subsequent disaster at Kasserine Pass was not that their radios were inadequate, but that their doctrine for using those radios was fundamentally flawed. The lessons of Kasserine Pass provoked immediate changes in American tactical doctrine. General Ernest Harman's after-action report, submitted to General Dwight Eisenhower in March 1943, identified specific failures in how American armored forces employed their communications capabilities. American tanks had been sent forward in small, uncoordinated groups, what Harman called sending them boiling down the road to contact the enemy. This violated the principle that radio-equipped tanks should advance as coordinated formations, maintaining constant communication, concentrating fire, and supporting each other through radio-directed maneuvers. The report emphasized that tanks, artillery, and infantry must coordinate their actions through maintained radio links. The communications technology was adequate. The tactical employment was not. American forces possessed superior radio equipment, but were using it to execute inferior tactics. General George Patton, who replaced Fredendall as two-corps commander on March 6, 1943, implemented the new doctrine with characteristic energy. Training exercises emphasized radio discipline, standardized communication procedures, and coordinated maneuvers executed through radio commands. Tank platoons practiced maintaining formation while advancing, with all vehicles monitoring the platoon net continuously. Battalion and company commanders learned to position themselves where they could maintain radio contact with higher headquarters while directing their own units. Forward air controllers were integrated into the ground command network, receiving target information and providing real-time updates on air support availability, all through coordinated radio communications. The transformation was rapid and dramatic. When American forces engaged German armor again at El Guettar on March 23, 1943, the tactical picture had changed fundamentally. El Guettar demonstrated what American armored doctrine looked like when properly executed. The 1st and 9th Infantry Divisions, reinforced by elements of the 1st Armored Division, established defensive positions in the hills, overlooking the Gafsa Gabes Road. When the German 10th Panzer Division attacked on March 23, they encountered a coordinated defense that exploited every advantage American radio technology provided. Tank destroyers positioned on the flanks maintained continuous radio contact with forward observers in the infantry positions. When German armor appeared, the observers transmitted precise coordinates to multiple tank destroyer platoons simultaneously. Artillery forward observers called fire missions that were executed within minutes, with corrections transmitted in real time as shells walked toward their targets. American tank units, rather than charging forward individually, maintained defensive positions in hull defilade, exposing only their turrets. Company commanders coordinated fire from their entire unit, directing multiple tanks to engage single German vehicles, a concentration of force made possible by instant radio communication of target information. The Germans attacked with approximately 50 Panzer IIs and Panzer IVs supported by infantry. They encountered a defense that was effectively invisible until they entered the kill zone, then found themselves engaged simultaneously by tanks, tank destroyers, artillery, and anti-tank guns, all coordinated through the American radio network. The battle lasted 9 hours. German attacks were repeatedly broken up by concentrated American defensive fire. Radio coordination allowed American forces to shift reserves rapidly to threatened points, concentrate fire on breakthrough attempts, and maintain coherent command control despite the chaos of combat. When the Germans finally withdrew, they had lost 30 tanks and accomplished nothing. American casualties were comparatively light. The same forces that had been defeated at Kasserine Pass 1 month earlier had demonstrated that superior radio technology, combined with proper tactical doctrine, created a decisive battlefield advantage. The technical superiority of FM over AM radio in armored warfare became increasingly apparent as the war progressed. Combat reports from both theaters, North Africa and later, Europe consistently noted specific differences in communications reliability under battlefield conditions. FM radio maintained clear communications in conditions where AM systems degraded or failed entirely. The electrical interference from tank engines and drive systems, which plagued AM transmissions with constant static and noise, had minimal effect on FM signals. Tank crews using the SCR-508 could conduct extended radio conversations even while moving at maximum speed across rough terrain conditions where AM communications became nearly unintelligible. The resistance to atmospheric interference provided another critical advantage. Thunderstorms, which were common in both North Africa and Northern Europe, severely degraded AM radio performance. Static crashes from lightning would overwhelm AM receivers, rendering them useless for periods ranging from minutes to hours. FM systems, by contrast, continued functioning with minimal degradation during electrical storms. German after-action reports from Tunisia and later campaigns repeatedly noted communications difficulties under conditions that American forces found entirely manageable. A panzer commander coordinating a company-level maneuver using Fugue 5 AM radios had to constantly repeat orders, confirm reception, and deal with communications breakdowns at critical moments. An American Sherman company commander using SCR-508 FM radios could issue complex orders once and receive immediate, clear acknowledgement from all subordinate units. The power differential also mattered. The SCR-508's 25-watt transmitter provided effective range of 7 miles, while moving sufficient for company and battalion-level operations across the typical engagement distances in both North Africa and Europe. The Fugue 5's 10-watt output limited effective range to 2 to 3 kilometers, adequate for platoon operations, but requiring relay systems for battalion-level coordination. These technical factors translated into tactical advantages that became more pronounced as the war progressed, and American forces developed more sophisticated combined arms tactics. The invasion of Sicily in July 1943 provided the first large-scale test of refined American armored doctrine in offensive operations. The 2nd Armored Division landed on the island's southern coast and immediately began exploiting the communications advantages that FM radio provided. Tank companies advanced in coordinated formations, maintaining constant radio contact. When lead elements encountered resistance, company commanders directed supporting units to flank or suppress the position while maintaining momentum, complex maneuvers, executed through brief radio commands that would have required flags or hand signals in armies lacking reliable communications. Battalion commanders positioned themselves centrally, monitoring reports from 3 or 4 company commanders simultaneously while maintaining contact with regimental headquarters. This allowed rapid concentration of force against German strongpoints. A typical engagement would develop with a lead company encountering resistance, the battalion commander assessing the situation through radio reports, and reserves being directed to the decisive point, all within minutes. The Germans defending Sicily used their standard radio equipment and tactics, but found themselves consistently outmaneuvered by American forces that appeared to coordinate effortlessly across distances where German communications became tenuous. A German company commander could coordinate his 4 or 5 platoons effectively using Fugue 5 radios, but coordination between multiple companies became difficult, and battalion-level maneuvers requiring simultaneous actions by separated units were challenging to execute. American forces, by contrast, found battalion and even regimental-level coordination straightforward. Colonel Maurice Rose, commanding Combat Command A of the 2nd Armored Division, routinely controlled 3 separate task forces spread across 5 to 10 miles of front, shifting reserves, redirecting advances, and concentrating combat power at decisive points all through the radio network that connected every American tank. By the time Sicily was secured in August 1943, American armored doctrine had evolved to fully exploit the technological advantages their radio systems provided. The principles were clear. Advance in coordinated formations, maintain continuous communications, concentrate fire through radio-directed target designation, and execute complex maneuvers through standardized radio procedures. These principles would be tested on a far larger scale when American forces landed in Normandy, June 6, 1944. The bocage country of Normandy presented armored forces with terrain that seemed designed to negate every advantage tanks possessed. Ancient hedgerows, thick earthen walls topped with vegetation, created a maze of small fields where visibility was measured in yards rather than miles. The close terrain favored defense, channeled movement, and isolated units into separate compartments, where coordination became extraordinarily difficult. German defenders used this terrain masterfully, positioning anti-tank guns and Panzerfaust teams at hedgerow corners where advancing tanks were forced to expose their vulnerable belly armor. American tank crews found themselves fighting a series of isolated engagements where traditional advantages, mobility, long-range firepower, coordinated maneuver seemed irrelevant. But the terrain that limited visual coordination made radio communications even more critical. Tank platoons advancing through the bocage maintained constant radio contact, sharing information about enemy positions, coordinating fire support, and warning following units about specific threats. When one Sherman discovered an anti-tank gun position through the unfortunate expedient of being hit by it, the crew's final radio transmission allowed other tanks to flank and destroy the position. Company commanders positioned themselves where they could maintain radio contact with all platoons while receiving instructions from battalion. This central coordination allowed American forces to maintain tactical coherence despite the fragmenting terrain. A typical company advance through the bocage involved 4 platoons moving along parallel routes, 1 or 2 hedgerows apart, maintaining radio contact, sharing intelligence about enemy positions, and concentrating fire when one element encountered resistance. German forces defending in the same terrain faced greater coordination challenges. The close bocage limited the effective range of their AM radios even further. Electrical interference from the hedgerows themselves, the earth and vegetation absorbed radio signals, combined with the inherent limitations of AM transmission, to fragment German units into isolated platoons, fighting separate battles. A German company commander attempting to coordinate 4 platoons spread across the bocage often found himself limited to communication with immediately adjacent units. Battalion-level coordination became extremely difficult. This contributed to the tactical pattern that emerged. German units fought skillfully at platoon level, but struggled to execute coordinated counterattacks or defensive maneuvers requiring multiple companies working in concert. The contrast became even more pronounced during American breakthrough attempts. Operation Cobra in late July 1944 demonstrated how superior communications enabled American armored divisions to exploit tactical success faster than German forces could respond. Operation Cobra began with a massive artillery and aerial bombardment that created a narrow penetration corridor south of Saint-Lô. Through this gap, 3 American armored divisions, the 2nd and 3rd Armored, and the 1st Infantry Division, with attached tank battalions, poured forward in a coordinated exploitation that moved faster than German forces could track, much less counter. The exploitation succeeded because American commanders could coordinate multiple divisions through their radio networks. Major General J. Lawton Collins, commanding 7th Corps, maintained contact with 3 separate armored division commanders simultaneously. Each division commander coordinated 3 combat commands. Each combat command controlled 2 to 4 battalion task forces. This multi-layered hierarchy functioned because reliable FM radio allowed clear communication at every level. When the 3rd Armored Division's Combat Command B encountered strong resistance at Coutances, Collins redirected the 2nd Armored Division's Combat Command A to bypass and encircle a complex maneuver involving thousands of vehicles across dozens of miles, executed through radio commands and coordinated timing. The entire maneuver was completed in less than 6 hours. German forces attempting to respond found their communications systems overwhelmed by the pace of American operations. By the time German commanders received reports of American positions, assessed the situation, formulated responses, and transmitted orders through their radio networks, the tactical picture had changed completely. American armored spearheads moved so rapidly that German radio communications simply could not keep pace. The Fug-5's shorter range and susceptibility to interference became critical liabilities when German units attempted to coordinate counterattacks across the distances involved in mobile warfare. A Panzer battalion commander who needed to coordinate with other battalions for a regimental-level counterattack often found himself unable to maintain reliable radio contact, not due to technical failure, but because the inherent limitations of AM radio systems over the required distances made consistent communication impossible. American forces exploited this communications disparity ruthlessly. When German counterattacks developed, American commanders received early warning from forward units, maintaining continuous radio watch. Artillery fire missions were called within minutes. Tank reserves were directed to threatened points through radio commands. Air support was coordinated through the ground-air radio network that had been developed and refined since Tunisia. The result was a systematic dismantling of German defensive positions that moved faster than German command systems could react. By autumn 1944, as American forces approached the German border, the cumulative advantages of superior radio technology had created operational capabilities that German forces struggled to counter. American armored divisions routinely executed complex operations requiring coordination across dozens of miles and multiple combat commands. A typical American armored division attack involved simultaneous advances by 3 separate combat commands, each operating semi-independently but coordinated through radio communications with division headquarters. Artillery battalions attached to each combat command provided immediate fire support, directed through radio networks that linked forward observers directly to fire direction centers. Close air support had become tightly integrated through procedures that allowed tank commanders to request airstrikes through their radio networks. Forward air controllers at battalion level received target requests, coordinated with air liaison officers at division headquarters, and directed aircraft to specific targets, all through a radio network that connected ground and air forces seamlessly. This level of coordination was simply not possible for German armored forces by late 1944. Material shortages affected German radio production and maintenance. Spare parts became scarce. Replacement radios were increasingly unavailable. Many German tanks went into action with partially functional or completely non-functional radio equipment. More fundamentally, the doctrine and training required to execute the complex radio-coordinated operations that American forces routinely accomplished had never been fully developed in the German army. German tactical excellence at platoon and company level remained formidable, but the ability to rapidly coordinate battalion, regimental, and divisional-level operations through radio networks had not been emphasized to the same degree in German training and doctrine. The result was an operational tempo mismatch. American forces could assess situations, formulate responses, transmit orders, and execute complex maneuvers faster than German forces could react, not because American soldiers were better individually, but because their communication systems enabled faster decision cycles and more flexible response to changing battlefield conditions. The Battle of the Bulge in December 1944 provided a final, dramatic test of communication systems under crisis conditions. The massive German offensive achieved complete tactical surprise, penetrating deep into American lines and threatening to split Allied forces in Belgium. The initial German success came partly through communications discipline. Radio silence prevented Allied intelligence from detecting the concentration of German forces before the attack. But once the battle began, the limitations of German communications technology and the advantages of American FM radio systems became apparent. As German spearheads penetrated American positions, they outran their radio networks. Panzer commanders leading the advance lost contact with higher headquarters as they moved beyond the effective range of their Fugue 5 systems. The need to maintain radio silence to preserve surprise meant that many German units lacked current intelligence about American positions and dispositions. American defenders, despite being surprised and initially overwhelmed, maintained their communications networks throughout the German advance. Isolated American units transmitted situation reports even while surrounded. Battalion and regimental commanders received continuous updates on German penetrations, allowing them to direct reserves to critical points and organize counterattacks. The rapid American response that eventually contained and reversed the German offensive relied fundamentally on superior communications. When General Eisenhower convened a conference of senior commanders at Verdun on December 19th, just 3 days after the German attack began, the decisions made there could be immediately transmitted through radio networks to divisions spread across hundreds of miles of front. General Patton's Third Army executed a 90-degree pivot from offensive operations in the Saar to a relief attack toward Bastogne, a massive reorientation involving multiple divisions, conducted in winter conditions over poor roads, coordinated entirely through radio communications that allowed continuous updates on road conditions, traffic control, and tactical dispositions. The relief of Bastogne on December 26th demonstrated communications coordination at its finest. The 4th Armoured Division's Combat Command R, advancing toward the surrounded 101st Airborne Division, maintained radio contact with artillery units, firing in support, with air support controllers directing fighter bombers to suppress German positions, and with the defenders in Bastogne itself, who provided real-time intelligence on German dispositions around the perimeter. When Combat Command R broke through German lines and established contact with the 101st Airborne, the link was established by radio before physical contact was made. Radio operators in the advancing tanks speaking directly with radio operators in Bastogne, coordinating the link-up and ensuring that American forces did not engage each other by mistake. The final campaigns in Germany during early 1945 saw American armored divisions operating with a level of sophistication that was unmatched by any other army in the world. The combination of superior radio technology, refined tactical doctrine, and extensive combat experience created armored forces capable of extraordinary operational flexibility. The crossing of the Rhine River at Remagen in March 1945 exploited a fleeting opportunity that depended entirely on rapid communications. When advance elements of the 9th Armoured Division discovered the Ludendorff Bridge intact, radio reports reached Corps headquarters within minutes. Orders to secure the bridge were transmitted immediately, and reinforcements were redirected through radio commands that altered the movement of thousands of vehicles across dozens of miles. The subsequent exploitation beyond the Rhine demonstrated American armored doctrine at its most effective. Multiple armored divisions, advancing along separate routes, maintained coordination through radio networks that allowed them to support each other, avoid interfering with each other's movements, and concentrate rapidly when German resistance stiffened. German forces attempting to contain the American penetrations found their ability to coordinate responses hampered by the degraded state of their communications systems. By early 1945, German radio equipment was increasingly scarce, spare parts unavailable, and trained radio operators in short supply. Many German units relied on motorcycle couriers to transmit orders, a system that worked adequately for static defensive positions, but was completely inadequate for the mobile warfare that characterized the final campaigns. The disparity in communications capability contributed directly to the collapse of organized German resistance in Western Germany during March and April 1945. American armored spearheads moved so rapidly and coordinated their movements so effectively that German defensive lines were penetrated before cohesive counterattacks could be organized. The statistical evidence from the war's final campaigns reveals the cumulative impact of communications superiority. American armored divisions routinely advanced 20 to 30 miles per day during exploitation operations, a pace that required continuous coordination of combat elements, logistics, convoys, and supporting arms across constantly changing terrain. German armored formations, even when properly equipped and fully manned, rarely achieved similar operational tempos during offensive operations. The casualty exchange ratios favored American forces increasingly as the war progressed. While German tanks often achieved superior kill ratios in individual engagements, the technical superiority of German armor and anti-tank weaponry remained significant. American forces consistently achieved better operational outcomes through superior coordination that allowed them to concentrate force, avoid unfavorable engagements, and call for supporting fires more rapidly than German forces could respond. The radio systems themselves became casualties of war that reveal the different approaches each side took. American forces prioritized radio maintenance and established elaborate supply chains to ensure that spare parts, replacement tubes, and frequency crystals remained available even during rapid advances. Technical manuals for the SCR-508 system included extensive troubleshooting procedures and repair instructions. Radio repairmen were organic to every armored battalion. German forces, constrained by material shortages and industrial bombing that disrupted production, increasingly found radio maintenance and replacement impossible. By 1945, many German tanks went into action with degraded or non-functional radio equipment, not because German technology was inferior, but because the industrial and logistical systems required to maintain complex electronic equipment had collapsed under the strain of total war. The legacy of World War II tank radio technology extended far beyond 1945. The principles proven in combat, that networked forces possess decisive advantages over isolated platforms, that communications quality affects tactical flexibility, that rapid coordination enables superior operational tempo, became fundamental to post-war military doctrine. The development of more sophisticated radio systems in subsequent decades built directly on the foundations laid during World War II. Frequency hopping radios to defeat jamming, satellite communications for beyond line-of-sight coordination, digital data links allowing transmission of graphics and tactical overlays all represent evolutionary improvements to the basic concept proven by the SCR-508 and similar systems, that reliable communications create force multiplication effects that can overcome significant material disadvantages in individual platforms. Modern military forces universally emphasize communication systems as critical combat multipliers. The U.S. Army's doctrine of network-centric warfare, developed during the 1990s and refined through combat in Iraq and Afghanistan, represents a direct descendant of the lessons learned when Sherman tanks coordinated through FM radio networks overwhelmed technically superior German armor that fought with less capable communications. The story of World War II tank radios illuminates a fundamental truth about military technology. Superior individual platforms matter less than superior systems integration. A Tiger tank was unquestionably superior to a Sherman in armor protection, firepower, and battlefield presence. But 4 Shermans coordinating their movements through clear, reliable FM radio communications could defeat a Tiger by exploiting superior tactical flexibility, fixing it from the front while flanking elements moved to positions where they could engage vulnerable areas. This principle that networks defeat nodes, that systems beat platforms, that coordination trumps individual capability remains as relevant today as it was on the battlefields of Tunisia, Normandy, and the Rhineland. The technical specifications tell part of the story. The SCR-508 system, 25 watts transmission power, FM modulation, 7-mile range while moving, crystal-controlled frequency selection, integrated intercom systems. The Fugue 5, 10 watts transmission power, AM modulation, 3-kilometer range, crystal-controlled frequency selection. The numbers reveal advantages but don't fully explain outcomes. What truly mattered was how these systems were employed. American doctrine emphasized continuous communication, radio discipline, standardized procedures, and multi-layered coordination from platoon through corps level. Training prepared tank crews not just to operate radios but to execute complex, coordinated maneuvers through radio commands. Maintenance systems ensured that radios remained functional even during extended operations. Tactical employment exploited the advantages that reliable communications provided. The combination of superior technology and superior doctrine created capabilities that German forces found increasingly difficult to counter. By 1944, experienced American tank commanders could coordinate company-level attacks through brief radio transmissions that would have required detailed written orders and face-to-face briefings in armies lacking reliable communications. Battalion commanders could direct reserves to threatened points within minutes of receiving reports of enemy action. Division commanders could coordinate simultaneous operations by separated combat commands across dozens of miles. These capabilities didn't emerge fully formed on D-Day. They developed through painful learning experiences in Tunisia, refinement in Sicily and Italy, and continuous adaptation based on combat results. The disaster at Kasserine Pass taught American forces that possessing superior radio technology meant nothing without proper tactical doctrine to exploit it. The subsequent victories demonstrated what became possible when technology and tactics aligned. Individual accounts from tank crews on both sides reveal the practical impact of communications systems in combat. Technical Sergeant Robert Elliott, a Sherman tank commander in the 3rd Armoured Division, described coordinating his platoon during an advance through Belgium in September 1944. "We could talk to each other constantly. The lieutenant would tell us where to go, what to watch for, when to stop. If one tank spotted something, he'd get on the radio immediately, and everyone knew about it. When we got hit, I could call for help, and the whole platoon would respond. That radio was as important as the gun." Hauptmann Otto Carius, a German tank ace commanding Tigers on the Eastern Front, noted the differences between German and American radio employment in his post-war memoir. "The Americans used their radios constantly, coordinating even small maneuvers. We preferred radio discipline, brief transmissions, to avoid detection. Their system created more flexible coordination, but also made them vulnerable to radio intelligence. Both approaches had merit. These perspectives reveal different philosophies. American forces accepted increased radio traffic as the price of superior coordination. German forces prioritized radio discipline and emissions security, limiting communications to essential transmissions. Both approaches reflected rational tactical choices, given each side's capabilities and circumstances. But the cumulative effect favored the American approach. The disadvantages of increased radio traffic, vulnerability to radio direction finding, potential for enemy intelligence gathering, increased electronic signature were outweighed by the advantages of superior coordination, faster reaction times, and more flexible tactical employment. The industrial dimensions of radio production reveal another aspect of the story. American factories produced SCR-508 radio systems by the tens of thousands. Multiple manufacturers, including RCA, General Electric, and Western Electric, built components to standardized specifications. Quality control ensured interoperability and reliability. The production system could surge rapidly to meet increased demand. German radio production faced greater constraints. Specialized manufacturers produced Fugue 5 components in smaller quantities. Allied bombing disrupted production. Material shortages limited output. By 1944, production could not keep pace with losses. Replacement radios became increasingly difficult to obtain. Spare parts disappeared from supply chains. These industrial realities created a widening gap in radio availability that complemented the technological differences. Not only were American radios technically superior for armored warfare applications, they were also available in unlimited quantities, while German radios became scarce commodities that could not be replaced when damaged or lost. The maintenance infrastructure supporting radio operations reflected similar disparities. American armored divisions included organic radio repair sections staffed by trained technicians with complete toolsets and adequate spare parts. Technical manuals provided detailed repair procedures. Field modifications to improve performance were documented and disseminated. The system ensured that radio equipment remained operational even during extended campaigns, far from fixed depots. German maintenance systems, though technically competent, struggled with material shortages and personnel losses that degraded capability over time. By late 1944, Many German units lacked trained radio technicians and spare parts for repairs. Radios that would have been repairable given adequate resources were instead abandoned or cannibalized for parts to keep other systems functioning. The integration of air support through ground-air radio networks represented another dimension, where American communications superiority created tactical advantages. The development of effective close air support required reliable radio communications between ground forces, requesting support and aircraft providing it. American forces developed elaborate procedures for coordinating air support through radio networks. Forward air controllers at battalion and regimental level maintained contact with tactical air control parties at airfields and with aircraft on station over the battlefield. Tank commanders could request air support through their radio networks, with requests forwarded through the chain to air controllers, who directed aircraft to specific targets. The system worked because American ground and air forces used compatible radio equipment and standardized procedures. A Sherman tank commander in contact with enemy armor could transmit a request for air support through his SCR-508, receive acknowledgement within minutes, and have fighter bombers attacking the target within a quarter hour, all coordinated through the radio network. German forces attempted similar coordination, but faced greater challenges. The Fugue-17 radio installed in ground support aircraft operated in frequency ranges compatible with Fugue-7 radios in command tanks, allowing ground-air communication. But the shorter range of German AM radios limited coordination distances. The less reliable communications in electrically noisy environments made maintaining contact difficult. The decreasing availability of German air power by 1944 meant that even effective radio coordination often produced no results. There were simply no aircraft available to respond to support requests. The cumulative effect of these disparities was air support that appeared seamlessly integrated for American forces, but remained sporadic and poorly coordinated for German forces, a difference rooted fundamentally in communications, technology and procedures, rather than aircrew skill or aircraft capability. The final assessment must acknowledge both what American radio superiority achieved and what it did not. Superior communications provided significant tactical advantages that contributed meaningfully to Allied victory. The ability to coordinate complex operations, concentrate force rapidly, call for supporting fires effectively, and maintain situational awareness across dispersed formations created capabilities that German forces found difficult to counter. But communications superiority did not overcome all German advantages. Individual German tanks, particularly Tigers and Panthers, remained technically superior to Shermans in armor and firepower. German tank crews, especially in veteran formations, retained high skill levels throughout the war. German tactical doctrine at small unit level remained effective. Superior radio communications helped American forces compensate for these German advantages, but did not eliminate them entirely. The combination of American industrial capacity, superior logistics, overwhelming air power, and effective radio communications created an overall superiority that proved decisive. Radio technology was one component of this larger system. Its importance should not be overstated. Many factors contributed to Allied victory. But neither should it be understated. Reliable communications enabled tactical and operational capabilities that materially affected campaign outcomes. The historical significance extends beyond World War II's specific circumstances. The principle that networked forces possess advantages over isolated platforms has been validated repeatedly in subsequent conflicts. Modern military forces universally prioritize communications systems as critical combat multipliers. Investment in communications infrastructure consumes significant portions of defense budgets. Tactical doctrine emphasizes network-centric warfare and distributed operations enabled by reliable communications. These modern approaches trace direct lineage to lessons learned when Sherman tanks coordinated through SCR-508 FM radios demonstrated that superior communications could multiply combat effectiveness that invisible radio waves. Connecting distributed forces could prove as important as armor thickness and gun caliber in determining battlefield outcomes. The specific numbers reveal the scale of American radio production and deployment. By war's end, over 50,000 SCR-508 radio systems had been manufactured and installed in American armored vehicles. Every Sherman tank, every Stuart light tank, every tank destroyer, every armored command vehicle carried this sophisticated communications system as standard equipment. The commitment represented by this production effort, the industrial capacity devoted to radio manufacturing, the trained personnel required to operate and maintain the systems, the tactical doctrine developed to exploit communications advantages, demonstrated that American military leadership understood the fundamental importance of networked operations. This understanding did not emerge fully formed. The pre-war army had debated radio requirements and tactical employment extensively. The disasters of early combat in North Africa revealed gaps between theoretical doctrine and practical battlefield requirements. But the system adapted rapidly, incorporating lessons learned, refining procedures, and developing capabilities that proved decisive. The contrast with German approaches reveals different national responses to similar challenges. German forces possessed technically competent radio equipment and sophisticated tactical doctrine, but the combination of technological choices, AM versus FM, resource constraints, and different doctrinal emphasis created an overall capability that proved inferior to the American system when tested in combat across multiple theaters and campaigns. The human dimension of radio communications, the tank crews who operated the systems, the commanders who coordinated operations through radio networks, the maintenance personnel who kept equipment functioning deserves recognition. Technical superiority meant nothing without skilled operators who understood both the capabilities and limitations of their equipment. American tank crews received extensive radio training that emphasized both technical operation and tactical employment. Radio discipline, proper procedures for transmitting and receiving messages, methods for maintaining communications under degraded conditions, all were drilled repeatedly until they became automatic, even under the stress of combat. This training investment paid dividends throughout the war. When technical sergeants like James Walker found themselves coordinating defensive fires while under attack at Kasserine Pass, their training allowed them to use radio systems effectively, despite the chaos and stress of combat. When battalion commanders needed to redirect reserves during the fluid battles of the pursuit across France, their understanding of radio capabilities and limitations allowed them to maintain coordination despite rapidly changing circumstances. The combination of superior technology, comprehensive training, adequate maintenance support, and tactical doctrine that exploited communications advantages created a system that proved greater than the sum of its parts, that multiplied combat effectiveness in ways that are difficult to measure precisely, but were apparent to participants on both sides. The legacy of World War II tank radio technology lives on in modern military communications systems that would have seemed like science fiction to the engineers who designed the SCR-508 inches, 1941. Satellite communications, frequency-hopping digital radios, encrypted data links, network-centric warfare concepts all represent evolutionary improvements to the fundamental principle that the SCR-508 proved in combat, that reliable communications multiply combat effectiveness. But the basic lessons remain unchanged. Technology alone does not guarantee success. It must be combined with appropriate tactical doctrine, adequate training, effective maintenance, and operational employment that exploits technological advantages. Superior individual platforms matter less than superior systems integration. Networks defeat nodes. Coordination trumps individual capability. These principles, proven on battlefields from Tunisia to the Rhineland when Sherman tanks coordinated through FM radio networks, remain as valid in the 21st century as they were in 1943. The technologies have evolved dramatically, but the fundamental truth endures, that forces which can coordinate effectively across time and space possess decisive advantages over forces that cannot, regardless of relative capabilities at the individual platform level. The story of American tank radio technology in World War II is ultimately a story about how invisible electromagnetic waves connecting distributed forces proved as important as visible armor and guns in determining battlefield outcomes. It is a lesson in how technological advantages must be exploited through appropriate doctrine and training to achieve their full potential. It is a reminder that victory in modern warfare comes not from individual superiority, but from effective integration of multiple capabilities into coherent systems that multiply combat effectiveness. And it is a testament to the American soldiers who operated these systems in combat, who maintained radio discipline under fire, who coordinated complex maneuvers through brief transmissions, who kept communications flowing even when surrounded and outnumbered, whose skill in exploiting technological advantages helped achieve victory in the largest mechanized conflict in human history.